In this video, we are going to focus on how to add vectors analytically. Now, we know that a vector is any quantity that have both magnitude and direction. Now, what if the vector do not run parallel to each other nor perpendicular to each other? Let's say the value of your A vector and your B vector. And the value of your vector A is actually 125 kilometers at east. And the value of your vector B is 115 kilometers at 30 degrees north of east. Now, how are we going to get the magnitude and the direction or the angle of our resultant force? But first, let's try to graph this one. We know your first vector or vector A is going to this direction, which has a value of 125. And your second vector is going to this direction, which has a value of 115 kilometers. Now, we know that we are going to count 30 degrees starting from your east going to north. Now, whenever you're going to graph two vectors using head-to-tail method, you should always have a mini Cartesian plane at the end of your last vector. So we know that this is your north and this is our east. And we're actually going to count 30 degrees starting from your east going to north. So you should have a value of 30 degrees right here. And for our resultant vector, again, we're going to have or to draw a straight line starting from the central axis going to the head of our last vector. So you should have a value of like this one. And this is actually our resultant vector. Now, how are we going to get again the magnitude and the direction of our resultant force? Now, try to look at this figure. It is not a triangle, but this is actually an example of obtuse triangle. Now, whenever you have an obtuse triangle, you are always going to use the law of cosine to get the magnitude or the value of the magnitude of the resultant vector. But keep in mind that whenever you have this triangle, it is necessary to write the symbols of all the three angles inside your triangle. Okay, let's try to include all the angles before we count or before we calculate our resultant vector. So we should know that the resultant vector is actually our C side or your hypotenuse. This should be our B side or adjacent side. And this is also again our A side or our opposite side. Now again, the opposite angle of your side C is actually your angle C. And the opposite of your side A is the angle of alpha. And the opposite of our side B has an angle of beta. So this is actually some of the symbols whenever we have an obtuse triangle. So let's try to have some space. Now again, this is an example of obtuse triangle. So for us to better get the magnitude or the value of the magnitude of the resultant vector, we are going to use the law of cosine, which has the formula of C squared is actually equals to A squared plus B squared minus 2AB cosine C. Now let's try to rewrite the value. Now again, C squared is what we are looking for, and the value of A, which is this one, the side A, is 115 squared, and the value of B, which is this one, 125 squared minus 2. Your A is 115 and your B is 125 and cosine C. Now, do we have the value of your angle C? Obviously none, but we could actually get the value of our vector C. Now again, we have a mini Cartesian plane here. And we know your quadrant 1 has 90 degrees and your quadrant 2 has a 90 degrees. Now we know that this has actually a value of 30 degrees. Now to get the value of this angle, we're going to add your 90 plus 90 because this value right here or the angle right here is 180 degrees minus 30 degrees. Now again, 180 degrees minus 30 degrees, and we should have the values or the value of 150 degrees. So it says that your angle here or your angle C, which is this angle, this one, has a value of 150 degrees. So let's try to rewrite the values. So now we know that the value of your C is actually equals to 100 50 degrees. Now let's try to compute these values. So we should get a value of 53,748.23. Again, cancel these two by having your square root. So C must equal to 231.84 kilometers. Now we know that the value of our magnitude of the resultant force has actually 231.84 kilometers. So that is the value of our resultant vector. Now we want to know the angle of our resultant vector, which is actually this one, or simply your angle A. Now, for an obtuse triangle, instead of using the SOHCAHTOA to find the angle, we're actually going to use the law of sine, which has the formula of this. So the formula of law of sine is actually side A over sine angle alpha, side B over angle sine beta, and side C over sine angle C. Now, so we have three different sub-formulas here. Now for us to be able to use this formula, we are just going to use only two sub-formulas. For us to be able to know which sub-formulas are we going to use, we need to identify which of these values or which of these sub-formulas have value. So let's try to have your first sub-formula, which is your A over sine A. Do we have the value of side A? We do have, which is 115 kilometers. Do we have the value of sine A or sine angle alpha? Basically, we do not have, but because angle alpha is what we are looking for, so this sub-formula here is actually needed to get the angle alpha. Now, sub-formula second, do we have the value of B? Yes, we do have, which is 125. But do we have the value of angle beta? We do not have. Can we get it? We cannot. How about your side C over angle sine C or sine angle C? Do we have the value of C? We do have, which is 231.84. Do we have the value of angle C? We do have. Again, the value of angle C is actually equals to 150 degrees. So basically, this formula or third sub-formula is also needed for us to get the angle of our resultant vector. So let's try to rewrite this formula. Now for our formula, we now have your side A over sine angle alpha and your side C over sine angle C. Now let's rewrite the given. The side A has a value of 115 kilometers, and just copy your sine A or sine angle A because this is what we are looking for. The value of C is 231.84 kilometers and sine angle C, which is 150 degrees. Now cross multiplication. 115 sine 150 degrees is actually equals to 231.84 sine A. Now let's try to have the value of first one. Now 115 sine 150 degrees is actually equals to 57.5. Now equals to 231.8 sine A. Now next thing to do is we have to get rid this 231.8 or 84. I'm sorry. Now next thing to do is we have to get rid this 231.84. So let's just going to divide this one with the same value, 231.84. So same here, 231.84. Now let's try to cancel this one and this one. So 57.5 divided by 231.84, you should have the value of 0.25 equals to sine alpha. Now transpose your sine to the other side. So sine -1 times 0.25 is equal to angle alpha. Now you should get the answer or the value of 14.36 degrees is equal to angle. So it says that the angle of your angle alpha or the angle of our resultant vector has a value of 14.36 degrees. And in what direction? We know that this is your east and this is your north. Simply, we are going to count 14.13 degrees starting from your east going to the north direction. So it should have the direction at north of east. So again, that is how we do it. So whenever we have an obtuse triangle, always use the law of cosine to get the value of the magnitude of the resultant force. And to get the angle of the resultant force, we are just going to use the law of sine. Now let's try to have another example. Now what if your vector A and vector B has the following values? Your vector A has a value of 10 newtons at west, and the value of vector B is 25 newtons at 25 degrees south of west. Now let's try to graph it first. So this should be our first vector, which has the value of 10 newtons. Now for our second vector, it's going to the south of west. So you should have a vector like this one, and it has 25 newtons. Now for our resultant vector, again, write a straight line starting from the central axis going to the head of your last vector. Now this is our resultant vector. Now again, when you try to look at this figure, it is also an example of obtuse triangle. Okay, so we know that your resultant force is actually your C side or hypotenuse. This should be our B side or the adjacent side, and this should be our A side or your opposite side. And the opposite angle of your side C is your angle C, and the opposite angle of side C is angle beta, and the opposite angle of side A is alpha angle. Now again, use the law of cosine to get the value of the magnitude of the resultant force. So C squared is equal to A squared plus B squared minus 2AB cosine C. Now rewrite the given. C squared is actually equal to the value of A, which is 25 squared. The value of B is 10 squared minus 2, 25 times 10 cosine C. Now again, we have to look the value of your C, which is this one. Now let's try to magnetize this one. Again, this is our Cartesian plane. We know that this is our vector 1 and vector 2. We should know that this angle has a 25 degrees value, because again, we're going to cut 25 degrees starting from your west going to the east or going to the south direction. And again, have a mini Cartesian plane right here, because again, this is a head to tail method of graphing. So we are going to count this, or we're going to look for the degrees or the value of this angle. Now we know that this quadrant has 90 degrees and this quadrant has 90 degrees. So basically, we're going to add 90 plus 90 minus 25. So 90 plus 90 is actually equals to 180 degrees minus 25. And you should get the value of 155 degrees. So the value of your angle C is 155 degrees. So let's try to rewrite the given values. Again, the value of your side or your angle C is 155 degrees. Okay, let's compute for this one. C squared is actually equals now to 1178.15. Now let's try to cancel this squared. Okay, then you should get the value of the square root of 1178.15. Then you should have the value of 34.32 newtons. So it says that the value of our magnitude of our resultant vector is actually equals to 34.32 newtons. Now let's try to find the angle of our resultant first, which is your angle alpha. Now again, have the formula of law of cosine or law of sine. So let's have the formula of law of sine. Side A over sine angle alpha is equal to side B over sine angle C. Now let's rewrite the given values. The value of A is 25 over sine A, because this is what we are looking for. And the value of C is actually equals to 34.32 over sine angle C, which is again 155 degrees. Then cross multiplication. 25 times sine 155 degrees is equal to 34.32 sine angle alpha. Now 25 sine 155, then you should get a value of 10.57 is equal to 34.32 sine angle A. Now bring down your 34.32 by dividing this one and 34.32. Now cancel these two Now 10.57 divided by 34.32, then you should have the value of 0.31 is equal to sine alpha. Transpose your sign, so sine negative 1.31 is equal to angle A. Now sine negative 1 times 0.31, then you should have the value of 17.93 degrees is equal to angle A. So it says that the angle of our resultant vector has a value of 17.93 degrees. Now at what direction? We know that this is our angle for our resultant vector. Now we're going to count 17.93 degrees starting from your west going to south. So we should know that our direction for our resultant vector is 17.93 degrees at south of west. So that is how we do it. Now again, whenever we have an obtuse triangle, we're going to use the law of sine and the law of cosine. But whenever we have a right triangle, we're going to use the SOHCAHTOA and the Pythagorean Theorem. So that is how we add vectors analytically. But these formulas are only applicable if you have two vectors. But if you have three or more vectors, having this formula is not applicable. So having three or more vectors, the best formula that we are going to do, or the best method that we are going to do, is the component method. Now on the next video tutorial, we're going to do the component method to add vectors analytically. So thank you for watching.